Here we're going to solve problem number 3. We start by setting the function we want to optimize, which is f of x, y, and parameters lambda, given by our function y squared plus 2x squared plus 2xy plus 2y plus lambda 1, first condition 3x plus y minus 40, and second condition x plus 2y minus 30. How do the conditions or restrictions come from? The first one is says that for the first type of glasses, swimming glasses or goggles, what you have is that 1 hour of preparation, so x is the first type, I take 1 hour of preparation and 3 hours of preparation and 1 hour of assembly. Let's erase this for a second, and x is the first type, but let's put here the preparation and let's put here the assembly, and this is the first time, Neptune. The second time, or mermaid or siren or whichever you want to call it, is given by 1 hour of preparation and 2 of assembly, so plus y plus 2y, and this is a mermaid. And we know this less than equal to 40 and this less than equal to 30. On the other hand, we are told that x and y are strictly positive, so no need for restriction here. Okay, you can look at the picture in the website, in the campus virtual, but basically the idea of the domain is something like this. It's a bit longer here and here, with level curves given by ellipses that are growing in size there. And you can see there, let me change to green, that the biggest ellipse which we're looking for already is this one here. This is the maximum, which is at the intersection of the two lines. The line of 3x plus y equals to 40 and x plus 2y equals to 30, where x equals to y equals to 10. Okay, so let's go about to solve and check this is the maximum. So we're going to do it in several ways. First of all, we're going to do it with Excel. So in the Campus Virtual, you'll find an Excel file in Campus Virtual. And in the sheet 1 of that Excel file, you will have a solution. I tell you x equals to y equals to 10 is the solution. With in the sheet 2, you will find the values of the multipliers. Lambda 1 is equals to 15.6 and lambda 2 is equals to 13.2. These two values you find on the sheet number 2. Right now the Excel is in Spanish, but you'll get it in English when I have the time to do it in another computer. Okay, let's check that this is correct, for which we have the partial of f with respect to x. Let's check our point is a maximum. So we have the partial of f with respect to x equals to, let's show the function, is 4x plus 2y plus 3 lambda 1 plus lambda 2. And the partial of f with respect to y is equals to 2y plus 2x plus 2 plus lambda 1 plus 2 lambda 2. We're assuming the points in intersection. We have g1 of 10, 10 is equals to 0 and g2 of 10, 10 is equals to 0. Actually, and this is satisfied, so now we'll check in the partial derivative. We have for the partial of f with respect to x is equals to 40 plus 20 plus 3 lambda 1 plus lambda 2 equals to 0, or 3 lambda 1 plus lambda 2 equals minus 60. And from the partial derivative of f with respect to y, we get something like lambda 1 plus 2 lambda 2 equals to minus 42. And we solve this and we get lambda 1 equals to minus 78 over 5, which in my calculator, 78 over 5, it gives me 15.6 minus 15.6, and lambda 2 equals to minus 66 over 5, which in my calculator gives me minus 13.2. As you can see, these are more or less the values we obtain here. Actually, these values on a sheet are rounded, on Excel are rounded, but these are the values and they're negatives and everything is satisfied, so this point is the maximum. It's a maximum where the maximum value is the function q of 1010, which is equals to 520. So what about the second part? If the company could increase the number, you see, it has two things. It has the number of preparation hours, which it has 40. Preparation has 40 hours. What if it could increase to 41 hours? And it has the assembly hours, which are 30. What if it could increase to this 31, but not both at the same time? Which one is better? Here, the solution for this, could be done again. And you can look in the Excel sheet. In the Excel, you have in sheet number 3, you have the solution for 41 hours. And you get that in this case, the approximate solution is x equals to 10 and y is equals to 9.8. With the value of the function q takes the value 536. While in sheet number 4, you have that x is equals to 9.8, y is equals to 11, with a value of the function 533. So from 40 hours of preparation and 30 hours of assembly, we get a solution of q equals to 520. Now if we put 41 hours of preparation and 30 hours of assembly, this looks bad. The assembly with q is equals to 536. While we have 40 hours of preparation and 31 hours of assembly, q is equals to 533. If you look carefully, the increase from here to here, which is 16, is approximately the value, or rather the negative value of the first multiplier. While from here to here, the increase is 13, which is approximately minus lambda 2. So for the case of a maximum, we have that increasing a restriction, say a restriction changes the value of the function by the negative of the multiplier. In this case, if we increase restriction 1 from 40 to 41, the function q changes by approximately minus 15.2. That was a multiplier. 15.6. That was a multiplier. Approximately increases by that much. While we change the restriction 2 from 30 to 31, what we have that q increases by approximately minus 13. So in our problem, what we have is, which one would be a better choice? Better choice. Well, as we are considering q is a cost, we want not to increase the cost as much as possible and rather increase the cost the least amount possible. So we have the second restriction. Increase to 31 is a better choice. And that's all.